All right, we're on our last objective of a third additional focus area, talking about different ways that EM waves can be used. So let's jump right into it. Quick review, like we do at the beginning of every one of these. Remember, electromagnetic waves. The word tells you what it's made of. Electro equals electric fields. Magnetic equals magnetic fields. So EM waves are vibrating both electric and magnetic fields, and they transfer energy, just like all waves transfer. Again, what makes electromagnetic waves special is they can transfer energy through outer space where there is no medium. So if you were in outer space and you were screaming at the top of your lungs right next to my ear, I wouldn't hear you because there's no medium. It's an emptiness out there. Sound is a wave that needs a medium. However, you'd still see me because light can travel through space without having a medium there. There are lots of different EM waves. We talked about some already: radio waves, microwaves, infrared, visible light. All of those have longer wavelengths, lower frequencies, and not a ton of energy. And then the more energetic, shorter wavelength, higher frequency waves are over here: ultraviolet, X-ray, and gamma rays. And because the fact that EM waves all have different wavelengths, frequencies, and energy, they can be used for different things. We already talked about how radio waves are very low energy and they can broadcast radio signals, TV signals, cell phone signals. Microwaves can go through walls, so they also carry cell phone signals. Ultraviolet light is high energy, so it can be actually used to clean and sterilize hospital equipment. X-rays, we know, can see through our skin. They have so much energy. And gamma rays, we said before, have so much energy that they can actually kill cancer cells. So let's jump into how kind of X-rays work. We know that X-rays are shorter wavelength and higher frequency. They're the second shortest wavelength. I just started in the chart over there. And the second shortest or second highest frequency, so they have a lot of energy. And because of that, they are able to actually go right through your skin and soft tissues, straight through the bones. Your bones and teeth are very dense, so the X-rays can't penetrate them. But because they can go through the softer stuff like your skin and tissues, you're able to get pictures like you see at the top over here, where your bones are, and you're able to see, are they broken, are they good, are they not? Same thing goes with like X-rays at the school or airport. The X-rays have enough energy to go through your book bag or your suitcase and see the metal things that are in there, and hopefully, if anything's dangerous, they detect it. PET scans and MRIs are both used for medical reasons. There's a little difference between them, so we're going to explain them really quickly and then just make sure you know which one uses which type of EM wave. So PET scans use gamma rays. We know gamma rays are very high energy, so these are important. The way a PET scan works, and you don't need all these details, just know that they use gamma rays, which are a lot of energy, but you get injected with a little bit of a radioactive tracer. So something that's radioactive in a large amount would be very dangerous, but you get a very small amount. And it goes to an organ that they're going to look at. Say you think you have heart or brain problems. The radioactive tracer ends up in your heart or brain at some point. They wait, they know how long it takes, and undergoes a chemical reaction. And the gamma rays are able to detect how that reaction is taking place, what's given off by that. Only something with a lot of energy like gamma rays will be effective in this. This picture over here is actually an MRI, even though they look similar to PET scans. But an MRI uses magnetic fields and radio waves. So again, PET scans use the high energy gamma rays. MRIs actually use low energy radio waves. And they're kind of making pictures of parts of your body that won't work very well with X-rays or CT scans or ultrasounds. You can actually see inside joints, ligaments, muscles. So it's big time if sports injuries, if you've ever had a favorite player maybe tear an MCL, which we know is a bad injury, the way they find out it's torn for sure is through an MRI. Let me get to the next slide here. Move my face around. X-rays, we said, are very energetic. We know they go through the soft tissues. We can see them, allows them to see our bones. But they can also go through cells, and they can damage the cell to the point where they mutate their DNA and cause cancer sometimes. So if you've ever been to the dentist and got an x-ray, or maybe you broke your arm or thought you broke your arm and got an x-ray, they actually put a big apron, big heavy apron made of lead over like your chest and your legs, part of your legs. And that reason is to protect the important organs that you have, the heart, your lungs, your kidneys, your liver, that sort of thing, because lead is so dense and thick the x-rays won't go through that. The last slide of this objective. How are EM waves used in astronomy, so in outer space? Well, radio telescopes, believe it or not, are usually used to look for extraterrestrial life signals. So we don't know if anything exists out there, but we're always looking, and we use radio telescopes to do it. These things are gigantic. You can kind of see in the picture how big they are, but the reason they're so big is they are trying to capture radio waves, which sometimes are as long as soccer fields. So they need to be big to catch that. Radio telescopes are also used to kind of get pictures or images of outer space, because some things in outer space give off those giant wavelengths like radio waves. And a lot of times, not these ones, but we will put telescopes into outer space, take them off Earth, because then they can get a clearer view of different things in the sky. Well, not really in the sky, in outer space, and gather more different types of EM waves than they would be able to on Earth once it goes through the whole atmosphere. And that's the end of our third additional focus.